Hey guys, I got your lecture video today. What I'm going to start doing, everybody close your Chromebooks. I'm going to go through this pretty quick. There's only one page of reading, but I'm going to start kind of pulling it up on this. I'm sorry for the name, but I have a generic student built in, which isn't like anybody's personal login. So I can kind of show you what it looks like from your end. So hopefully I can show you how to get to the things you need to get to answer the questions. So we have two things assigned today. One of them is assignment. The other one is a reading, which isn't assigned for a grade, but I assign it to help you get to the part of the book where you can answer the questions. So I'm going to open up both of these. You can double click on this or not, like double, you know what I mean, double tap on it. Hello? Yes, no problem. Trenton and Julian, Mr. Stone wants to see you. Yeah.
Man, are you turning into a bad dude?
Front row.
I like
Front
that.
row.
That's not me shaking.
I told you. Told you.
Hurry back. Keep that mask above your nose. All right. So listen. What we're doing today, we have one assignment, which is constructed response. I'm going to try to go through this quickly so you have plenty of time to fill out your answers and get everything done. What we have here is the reading. I want you to open this up in a different tab. You can alt click on it or click two fingers at the same time on it, and it will allow you to open it up in a different tab. And then click on the assignment itself, which will open up, and you hit take assessment. It takes you to it. There are 3 questions, but there's actually a lot more than just 3 questions. It shouldn't take you a long time, but I want to show you how to get these done. So first off, let's talk about minor bodies in the solar system. Here's the reading. There's only one page of reading for this section, so you should be able to find all of your answers that they're asking you about on this one page. So they talk about minor bodies. Basically, anything that's not a planet is considered a minor body. So we have asteroids, meteors, comets, dwarf planets, and other things like the asteroid belt, the Kuiper belt, that kind of stuff.
So what is Pluto?
Pluto is a dwarf planet. So it is technically a minor body. It's also a body in the Kuiper belt, and so we'll talk about that for a second. So they kind of go through some of these things, and we've already kind of talked about Pluto a little bit, why it's not a planet. What?
How is it not a planet, but it's a dwarf planet?
Basically because it's really small and it's out in a part of the solar system called the Kuiper Belt that has a whole bunch of other stuff in it. And it also comes in between Neptune and the sun. And so is it the furthest out planet? Is it not furthest out? Basically, it has a lot of characteristics that make us uncertain about its future. Since we've discovered Pluto, it hasn't even gone halfway around the sun yet. And so there's still a lot of things that could happen to Pluto where it's not even around in the future, or not in the same space that it is in the solar system. So maybe at some point in time, Pluto gets put back into a planet. There's a lot of people that want it to be that way, but we're still trying to work out exactly what is a planet and what is not a planet, because there's not just a clear line. There's some things that fall in a gray area of, it's kind of big enough to be a planet. Yeah, it orbits the sun, but it also has some other issues. Yeah.
So, like you said, it goes around Neptune.
It comes in between Neptune and the sun, and then it goes back out.
What if it was Neptune's moon?
It's not. So, Pluto is a minor body. It is a dwarf planet, which is a new classification that we created. So it's small, and it does orbit around the sun, but it's not a full category planet. We've kind of downgraded a little bit. What they're going to talk about in this section are asteroids, which asteroids are kind of the same things as meteors, but they're bigger. So they talk about the largest asteroid being more than 900 kilometers. Generally, your small asteroids are 50 kilometers in diameter. So 50 kilometers is probably what, like 30-something miles? I don't know the exact equivalency, but they're pretty big rocks, where your asteroid or your meteors are generally going to be smaller rocks. And so what's the difference between an asteroid or meteor? In general, it's just the size. So when they talk about asteroids, there are different types. They have carbonaceous, they have metallic, they have rocky asteroids, which they also call siliceous because they're made of silica. You can just call them rocky asteroids. But really, rocky asteroids and stony or metallic asteroids are the two major different categories. So asteroids are going to be bigger. They're also going to have more of an orbit around the sun or maybe around a different planet, where meteors are kind of a little bit harder to track and know exactly what's going on with them. If we scroll down a little bit, they start to talk about meteors. One of the things I want to talk about real quickly about meteors is we have 3 different names for meteors. There's meteoroids, meteors, and meteorites. And those names are based on where they're at in the sky or on the ground. So the meteoroid is in space. When they come through the atmosphere and they turn into a shooting star and they start to burn up in the atmosphere, that's when they're called a meteor. And if they survive the atmosphere and hit the ground and you can go and pick it up, then as a rock, it's called a meteorite. Okay, so those are your 3 names. Meteoroid is in space. Meteor is coming down to Earth. And once it hits Earth, it becomes a meteorite. And so they will ask you a question about that a little bit. Most meteors or meteorites, once they actually get here, are metallic. This is 1 centimeter right here, I think they're saying. And so this one's, maybe, I don't know, centimeters. You're probably talking about that big. So that's a pretty big one. This one does kind of look rocky, but it could be metallic a little bit. But a lot of meteors have metals and are made of metal substances. So they talk about an iron meteor formed from the core of an ancient planet that got smashed. So here's where they describe meteoroids, meteors, and meteorites. And their different names and their positions in the solar system. Comets. What's the difference between a comet and an asteroid? Comet's made of ice, and what does it have that comes off the end of it? It has the tail. Just remember, the tail doesn't show you which way the comet's pointing. So down here, they have a little bit of a description. Here's your ion tail. Here's your dust tail. This one you don't really see unless you have a really, really good telescope. The dust tail kind of follows where it's going. So it's actually going this way. But the sun is over here, and so your ion tail, the one you can see, actually always points away from the sun. So it's not always pointing to the back of the comet. Sometimes it's pointing to the front of the comet. It depends on which way the comet's going compared to the sun. So know that comets are generally very big. They're made of ice, sometimes a little dirt. They call them dirty snowballs because it's usually a mixture. Very rarely is it just a pure chunk of ice.
How big are they?
It depends on the comet. Some of them are really, really big. Once they get really small, because they kind of get heated up every time they go towards the sun, they probably don't last for very long. And so it's got to be pretty big to be able to go around the sun several times and not get completely melted away in a way. It doesn't really melt into a liquid. It turns into ions, like individual atoms. But yeah, if they get close to the sun, they get heated up. They lose a certain amount of mass every time. Depends on the comet. And they're changing speeds. As they're coming in towards the sun, they're going faster. As they're going away from the sun, they slow down because the sun's gravity is pulling them back towards it. So it really depends on the size of the comet, how far out it goes, and how close it comes to the sun is how fast it goes. So they talk about comets. We have long period comets and short period comets. The long period comets take more than 200 years to orbit the sun. So if you happen to be able to see one of those, you're probably only going to see it once in your lifetime. Short period comets can come by more often, and you might be able to see them 2 or 3 times in your lifetime. And then we go down here to the bottom, and we're going to talk about other different areas. So the Oort cloud, we saw that in the video. The Oort cloud is very, very far out. It's like the outermost reaches of our solar system. It's a bunch of different comets and small pieces of rocks. A lot of them don't ever come in near the sun. Some of them do as long period comets because it takes so long to get in here and get back out. But yeah, their example is the Hale-Bopp comet. and several others that we've seen. So that's very, very far out. Here's an example. Well, I tried to turn the lights out even more. So here's the sun, Earth, Mars, Jupiter, Saturn, Neptune, Pluto. Right here around Neptune and Pluto is the Kuiper Belt, which is where Pluto is. Way out here, more than double the distance of Pluto, is the Oort cloud. So the Oort cloud is very, very far out, and this is where a lot of our comets come from. So now they talk about trans-Neptunian objects in the Kuiper Belt. The issue with Pluto is it's in the Kuiper Belt, so there's a lot of other junk around it, and that's one of the criteria they use to keep Pluto from being a planet, is that it hasn't cleared its orbit. And basically what that means is as Pluto goes around the sun, there's a really good chance that it's going to pick up other objects. It might collide with other objects, and it may not be around. I don't think that they're really worried about this. It may not be around for a really long time. Maybe several 100,000 years in the future, Pluto collides with something pretty big and gets pushed off orbit and ends up like as a moon of Jupiter or Saturn, or coming even further in. There's all sorts of weird things that can happen. I think we discovered Pluto in around 1930. So they talk about Pluto here, discovered in 1930. Since then, it has only gone around the sun less than half of a time. It takes Pluto 248 years to go around the sun. We've only known about it for about 90 years. So it has not even gone around halfway around the sun since we first discovered Pluto. And so we need to do a lot more studying before we make Pluto like a permanent planet in the group of planets. Know that no matter what we call Pluto, it doesn't change what it is. Like, it is what it is. What name we put on it doesn't really matter to Pluto. It's just going to be out there doing its thing. They call Pluto trans-Neptunian, and that's the thing. Most of the time, Pluto would be the furthest planet out if it were a planet. But sometimes it comes in between Neptune and the sun, which is why they call it trans-Neptunian. Trans means travel or crossing, and Neptune means it's coming inside of Neptune. Yes? Huh? That's just its orbit. It has a weird orbit that's more like an egg shape than a circle. And so part of the orbit, it's coming inside Neptune. Part of the orbit, it's staying outside. So heads up. You have your sun here, and let's say this is Neptune's orbit. Pluto, I'll do a dotted line for Pluto. Pluto's coming like this. So sometimes it comes in, and then it goes back out, and then it comes back in and goes back out. So this is kind of exaggerated just to prove the point. But yeah, Neptune would be here, and Pluto would be here. And so sometimes, like 2 times during the year, it's actually closer than Neptune, and then 2 times out of the year, it's actually further away from Neptune. That being said, I don't know that they're on the same orbital plane, so I don't think like Pluto could hit Neptune. But that is one of the issues that they worry about when trying to figure out exactly what Pluto is. Let's see. Hey. So I think that's pretty much it. I know I went through that fast, but I want everybody to have plenty of time to do the assignment. Don't open it yet. I want to show you some things. Because if you're opening it and you're looking at it, you're not listening to me. So yeah, close it. Here's the assessment. The first question, you need to make a chart. Put some characteristics over here. They can be very vague and broad. Like the first one I would do would be size. And what size are comets, asteroids, and meteors? You don't have to give me like specific sizes. Are comets large or small? They're going to be pretty large. Asteroids versus meteors, which one's large and which one's small? Yeah, asteroids are larger, meteors are smaller. And so do that kind of thing. You can do size, you can do composition, like what are comets made out of? What are asteroids made out of? What are meteors made out of? And find 2 other things. No, not taste, but find 2 other things to try to describe them. Use the reading, and just make a simple chart here. You don't have to put sentences or anything. Just give me a couple words to make this a working chart. Close your Chromebook. God, close your Chromebooks. Now, there's a couple other ones. I guess you got to go question by question. So question 2, explain the difference between meteors, meteoroids, and meteorites. So give me that. And also answer this one. Explain how a comet's tail forms. So talk about the sun heating up the comet, vaporizing the ice, and the ions leaving the comet in the opposite direction of the sun. And then the next one, they got a couple questions on the next one. What is the difference between Charon and Pluto? Charon is Pluto's moon. It's actually pretty large for a moon, but Charon is actually the one that orbits Pluto. It's almost like a symbiotic thing, but Pluto's definitely bigger and Charon's definitely orbiting around it. So explain that a little bit between a dwarf planet and a moon. Even though size shouldn't really be a matter, because Pluto is actually smaller than our moon. It's about what you orbit and how you orbit. So Pluto is orbiting the sun, which is what makes it a dwarf planet. Charon is orbiting Pluto, which is what makes it a moon. And so it's about what you orbit here. Why are Charon and Pluto considered Kuiper Belt objects? Because that's the area of space in our solar system they're in. They're out there with all the other Kuiper Belt objects, all the asteroids and meteors that are out there. And then that's the last one. So that shouldn't be too bad. You can open your Chromebooks now. People online, if you have any questions, please email me. Make sure that you're submitting some answers for each of these questions and getting something in that I can grade and give you a good grade for. So if you have questions, send me an email. I will post this video as soon as I can. Thank you and have a nice day.